Analysis of general amplifier. Now we have to derive 4 relations, and based on these 4 relations the numerical can be asked. You will get one question of 6 marks on Q point, either VGT or FET. One question of 6 marks on this article, either this derivation or numerical on this derivation. Numericals are very easy. Derivation is little bit complicated, but I will explain it in easiest way. But while observing the video, you observe it carefully, you practice on it, you note it down in your notebook, then it is very easy. Analysis of general amplifier. Now using BJT, we have to form amplifier. Now what is amplifier? Amplifier means to increase the strength of weak signal. You have studied it in first year. Amplifier, to increase the strength of weak signal. Millivolt signal is converted into volt signal. Millivolt into volt. Input is millivolt, output is volt. This is amplification. Right? So analysis of general amplifier, we have to form an amplifier using BJT or a 2-port network. We have to apply sine wave at the input and we have to take the output across the load. So in previous lecture, this block we have studied. A 2-port network, right? BJT, right? So using 2-port network, we have to form an amplifier. Amplifier, that means we have to apply sine wave at the input and we have to take output. So this is input side, this is output side. This is sine wave. It is always applied. The generator through which we are applying sine wave, it has internal resistance, that is indicated as RS. The instrument through which we are applying a sine wave is known as a sine wave generator. It has internal resistance RS. And to take the output, we have to connect some load across the output. So this is RN. So this is amplifier. A 2-port network block, this we have studied in previous lecture. To that block, sine wave input is applied and we will take the output. So for this block, this is input current I1, input voltage V1, we have studied it yesterday. This is output current I2, output voltage V2. Right? So I am indicating one additional current. As load is connected, I am indicating the current IL. V1, V2, I1, I2. This we have studied in previous lecture. A 2-port network, input voltage, input current, output current. Now since I have connected a load, I am indicating load current through the resistance. So using this amplifier, we have to analyze this amplifier. We have to determine 4 parameters. First is current gain. Current gain. Gain notation used is A. A is the notation used for gain. Current gain, IS script. This first formula we have to derive is for current gain. Second, input resistance. R is the resistance input, I subscript. Third, voltage gain. A is the notation for gain, V subscript. And fourth one is output resistance. R is the resistance output, RO dash. So we have to derive 4 formulae. Current gain AI, input resistance RI, voltage gain AV, output resistance RO dash. So input resistance in the input terminals. These two are the input terminals. So I am indicating arrow here. This is RI. input resistance. Current gain, ratio of output current and input current. Input resistance, resistance between the input terminals, input voltage upon input current. Voltage gain, ratio of output voltage upon input voltage. Output resistance, resistance in the output terminals. These are the output terminals of transistor. So this is RO dash. Input terminals of two-port network RI, output terminal of two-port network RO dash, and from this side this is RO. Resistance between these two terminals is indicated as RO dash. This is RO dash, parallel with RA will be R. Right? So we have to derive relation for these four. Now see the derivation steps carefully. So in previous lecture we have two equations defining H parameters. I am writing those two equations again. This equation we have studied in previous lecture. And second is I2 is equal to these two equations we have studied in previous lecture. V1 is equal to HI1 plus HRV2 and I2 is equal to HF1 plus HV2. Now first we will derive relation for AI. Current gain AI. Ratio of output current and input current. Output current is IL, input current is I1. Or IL and I2 are in opposite direction. IL and I2 are in opposite direction. So IL is equal to minus I2. This is suppose number 3. Now to derive a relation means what? To derive a relation means what? We have 6 known parameters. Value of RS is known to us. Value of RL is known to us. HI, HR, HF, HO are also known to us. So 6 parameters are known to us. All H parameters, HI, HR, HF, HO, RS and RL are known to us. So we have to derive the formula in terms of RS, RL, HI, HR, HF, HO. So we have to derive the relation between for each one in terms of H parameters and the resistors. That we have to do. Right? So now AI is minus I2 upon I1. I2 upon I1 we are having one of the equation. We are having equation for I2. Equation number 2. From 2. I2 is equal to HF I1 plus HO. I2 upon I1. Only two variables are required, I2 and I1. Here it is I2, here it is I1. V2 is not required here. I2, I1, I2, I1. Only we have to derive in terms of I2 and I1. Here it is I2, here it is I1. Here we have to define now V2 in terms of I2 or I1. So see what I am doing. V2 is equal to, from figure, V2 is voltage across this resistance. Current into resistance is V. V is equal to IR. So V2 is equal to IL into RL. But we require either I2 or I1. Now IL is equal to minus I2. Here I have put IL equal to minus I2. So this is minus I2 RL. Put in 4. Here. Put here. So I2 is equal to HF I1 minus HO I2 RL. So take this term to this side. I2 plus HO I2 RL is equal to HF I1. I2 into bracket 1 plus HO RL equal to HF into I1. Therefore, cross multiplication I2 upon I1 is equal to HF upon 1 plus HO RL. Right? Put this I2 upon I1 in equation number 3. Put in 3. So, first formula AI is equal to, if this is put in equation number 3, AI is equal to minus I2 I1. So, this is first formula that is derived, right? Now, second, input resistance Ri equal to V1 upon I1. Suppose this is equation number 5. V1 upon I1. We are having equation for V1. So I am writing that equation. V1 is equal to HI I1 plus HR V2. V1 upon I1. This is term of V1, this is term of I1. So again, V2 is not required. V2 is equal to, here, V2 is equal to minus I2 RL. V2 is equal to minus I2 RL. And from equation 3, minus I2 will be AI into I1. Here we want terms of V1 and I1. This is V1, this is I1. We have to eliminate V2 either in terms of V1 or I1. Now V2 I have written from here minus I2 RL, and from 3 minus I2 will be AI into I1 if it is cross multiplied. So it is AI into I1 into RL from 3. So put this V2 here. Then we get V1 is equal to HI I1 plus HR AI I1 RN. I1 common HI plus HR AI RN. V1 upon I1 is equal to HI plus HR AI RN. And put this in 5. Put in 5. So V1 upon I1 is nothing but Ri. That will be HI plus HR AI RL. So second formula that is derived is Ri is equal to HI plus HR AI. That is second formula. Current again this one, input resistance this one. Is that clear? You have to practice on it. Now third one is voltage gain. Voltage gain. AB. Output voltage upon input voltage. V2 upon V1. Suppose this is equation number 6. Now put V2 equal to AI I1 RL from 6. Put V2 equal to AI I1 RL from equation 6. So AV is equal to V1 upon I1 is Ri. The definition of Ri is V1 upon I1. So it is AI into RL upon Ri. Since Ri is equal to V1 upon, So third formula which we have derived is right, V2 upon V1, V2 is equal to AI1 RL from equation number 6, I1 upon V1 is 1 by R. And now last output resistance R dash. Now last formula for output resistance R dash. Input is a series circuit, output is parallel circuit. So for parallel circuit, resistance is defined as R dash is 1 upon output resistance, output voltage upon output current. This is output voltage upon output current, but put in different way, 1 upon I2 by V2. Right? Resistance is defined as voltage upon current, but here it is defined as 1 upon current by voltage. While calculating output resistance, we have to keep input voltage 0, Vs 0. So if input is 0, then the circuit appear like this. This is 0. So I have shorted this part. This is current I1, this is RSC. And this voltage is V1. I have drawn this much of part only, this much of part, by putting Vs 0. Right? So I2 by V2, we are having equation of I2 here. We have from 2 I2 equal to HF I1 plus HO V2. Suppose this is number 7, this is number 8. I2 upon V2, we would require terms of I2 and V2 only. I2, V2. I1 is not required. We have to eliminate I1 either in terms of I2 or V2. So I am writing KVL equation. KVL to above figure. Minus RS I1 minus V1 is equal to 0. Right? Put V1 from equation 1. So minus RS I1 minus HI I1 minus HR V2 is equal to 0. This is taken to this side. Now put this I1 in equation number 8. Resistance is 1 upon current by voltage. We have equation for I2 that I have written here. We require terms of I2 and V2 only. I2 and V2. I1 is not required. So to eliminate I1, what I have written? KVL to this loop. Minus RS into I1 minus V1 is equal to 0. Now V1 is put from equation number 1. Minus RS I1 and V1 minus HI I1 minus HR V2. I1 common from these two. I1 into RS plus HI. I1 is equal to put this I1 in equation number 8. Right? I am putting this I1 here. So I2 upon V2 will be this one. I2 upon V2 will be this one. So put this I2 upon V2 here. So lastly, RO dash is equal to 1 upon HO minus HF HR upon RS plus H. That is output resistance. And finally, output resistance RO will be RO dash parallel with RO. So these are the 5 relations which we have to use while solving the numericals. Keep it okay? Correct? So these 5 formulae we have derived now. So this derivation can be also asked in the exam for 6 marks. Or depending on this formulae we have to solve the numericals. All the values are given to you. HF, HO, HR, HI, all are given. RL, RS, everything is given. You have to only put down the values in formulae and you have to solve. But it is not that easy. You have to put down the value, you have to calculate the answer and you check whether you can handle the calculator properly or not. It seems easy, but while solving the numericals, you may face many difficulties, right? So, now we have to solve the numericals, but before solving the numericals, a circuit is given to you and you are asked to calculate this. For the figure shown, calculate AI, RI, AV, RO. This is the question. But you have to draw the AC equivalent of that figure and then you have to use the formula. You have to draw the AC equivalent whether it is asked or not to draw the AC equivalent. You have to draw the AC equivalent and then you have to use the formula. Now, how to draw the AC equivalent of given figure? Only 2 steps are there. First step, short the capacitors. Short the capacitors. In the figure, how many capacitors are connected? You have to short all those capacitors. And second step, connect DC sources. Since we are drawing AC current, there are DC voltages in the figure. That DC voltages you have to connect them to ground. That means you have to reduce them to 0. To reduce the DC voltage to 0, you have to connect it to ground. Connect the DC sources to ground. Only 2 steps. Short the capacitor and connect the DC voltages to ground. So I will give you one example. I will draw the figure and I will show you how to draw the AC current. This is the figure, and for this figure you have to calculate AI, RI, AV, RO, but first you have to draw the AC current. This is sine wave, AC sine wave. This is DC voltage. VCC is DC voltage. You have to connect it to ground, and you have to short the capacitor. This is the capacitor. This is the capacitor. Now, how to draw the AC current? This is base. This is connector. This is emitter. I am drawing the AC current. Resistor, capacitor short. Capacitor is shorted, right? Base, emitter. Now RL is connected in collector and VCC. RL is connected in collector and VCC. VCC is the DC voltage, Q point. Q point में हमने use किया इसको. Q point is DC analysis. VCC is the DC voltage. You have to connect it to ground. Connect the DC sources to ground. VCC को ground के साथ connect करना है. इस लाइन के साथ ये ग्राउंड है. You have to connect VCC. So RL is connected between collector and VCC. So it will now appear between collector and you have to connect VCC to ground. So RL, which is connected between collector and VCC, now we have to connect it between collector and ground. This is collector, this is ground. Between collector and ground, and this capacitor again shorted. This is known as AC current. So the figure is given to you. You have to draw the AC current. There are two steps only. Short the capacitors and connect the DC supply to ground. So collector, the resistance is appearing between collector and VCC. We have to connect this to ground. So that resistance will appear between collector and ground. So this is collector and this is ground. I have connected it between collector and ground. That is known as AC current. So figure is given to you. Draw the AC current. All the values RS, RL, HI, HR, HF, HO all are given. Put down simply in the formula and solve the numerical. Right? So now I will give you one numerical. I will solve the numerical and then two numericals will be uploaded on your WhatsApp number. So same figure 1K, 4K, HI is equal to 1.1K, HR equal to 2.5 into 10 raised to minus 4, HF equal to 50 and HO equal to 25 microampere per volts. So for this figure you have to calculate AI, RI, AV and R. The figure is given to you. This is 1 kilo ohm, RL is 4 kilo ohm, HI, HR, HF, HO value are given. So for this figure we will draw the AC current. This is that AC current 1K, 4K. All the values are given. 25 microampere per volts can be represented as 1 upon 40. Right? So directly apply formula. Figure is given. Draw this AC current and now start. 1 AI minus HF upon 1 plus HORA. Formula. Minus HF. This is HF. Upon 1 plus RL is 4K. And HO is 1 upon 40K. So no need to convert 10 raised to 3. 4 into 10 raised to 3, 40 into 10 raised to 3, K cancel. RL is 4K and HO is 1 upon 40. Right? So this will be approximately. You yourself solve the numerical. Huh? You solve, use the calculator and tally whether the answers are correct or not. Your answer should be approximately to my answers. RI is equal to second formula. HI plus HR, AI, RL. HI 1.1K plus HR 2.5 into 10 raised to minus 4 into AI minus 45.45 into RL. So if you calculate this, this will be approximately 1.05. Third, AV is equal to AI into RL upon RI. AI is minus 45.45, RL is 4 upon RI is 1.05. So if you calculate this, approximately minus 170. Three answers are over. And fourth, RO dash 1 upon HO minus HF HR upon RS plus HI is equal to 1 upon HO is 1 upon 40 minus HF is 50, HR is 2.5 into 10 raised to minus 4 upon RS is 1 plus HI is 1. This calculation you have to calculate carefully, right? So this R dash will be approximately 53. You check the answers, huh? And then finally fifth, RO is equal to RO dash parallel with RL. RO dash is 53, parallel with RL is 4. Figure is given, RS, RL, all values are given, draw the AC current and simply put the values in the formula. And you yourself calculate this calculation particularly. 5 formulae you have to mug up those formulae. This is for common emitter. Now second numerical common base and third numerical common collector. These two numericals I will provide you the notes on your WhatsApp number. This is one numerical. Right? AI, RI, AV, RO. Current gain ratio of output current and input current. So it is unitless. Voltage gain ratio of output voltage and input voltage. Unitless. resistance unit of kilo ohms, resistance unit of kilo ohms. Since all the resistors are given in kilo, so we will assign the unit of kilo, right? Okay. So derivation and numerical. Observe and listen the video very carefully and note it down while observing in your notebook and practice on it. Okay, bye.